Good morning. Uh, the lecture of today is about the sustainable production of the membranes. You know, in recent years, the environmental aspect of any fabrication is very important. And we must go to a green technology for production of any products. In the fabrication of membranes, we also select green polymers, green solvents, and generally green methods for fabrication of membranes. The application of the membranes, as before say, that no high environmental problems, because the separation is a physical separation, and we very low use the chemicals, and therefore only the consumption of energy is important in membrane processing, and we try to reduce the energy consumption, because for producing of the electricity and energy, the carbon dioxide emission can be pollute the air and the world. But the main problem in the membrane fabrication is solvents. Because, as discussed, for fabrication of membranes, we first usually dissolve the polymer in a solvent and prepare a casting solution. And after casting this solution as a sheet or as a hollow fiber, as a tube, we want to separate the phase. And in this case, we use non-solvent induced, vapor induced, thermal induced, and others process for fabrication of membrane. And in this case, we must remove solvent from the membrane. And 80%, normally 80% of the casting solution is solvent. And after fabrication of membrane, this solvent should be managed. And this solvent is usually toxic and cause environmental problems. Therefore, in development of greener and sustainable membranes, we mostly focus on change of the traditional solvents with greener one. The second problem is the polymer, but the environmental aspect of polymer is very lower than the solvent, because the use of polymers is not very dangerous, and we can replace them with biopolymers if we have find the biopolymer with the properties near the usual and conventional polymers. There are strategies for fabrication of green membranes that you see, that one is the greener solvent for casting, coating, cross-linking, and interfacial polymerization. In all processes of membrane fabrication, we have the main part of our solution is solvent, and we must use a greener one with low toxicity, low volatility, when the solvent can be vaporized and go to the atmosphere, can cause to the environmental problems. We can reduce the waste minimizing step. in the production step, for example, with the reducing of the batch size, we can reduce the consumption of solvents, okay? Or we can minimize energy consumption with use of the novel and new pumps that use very, very low energy. We can reduce the energy consumption in the membrane fabrication. In the membrane fabrication industrial, we usually have some motors for rolling and some pumps for pumping of the liquids. And we have no energy consumption, but if we can reduce this energy consumption, we also we can reduce the environmental problems. Therefore, in membrane fabrication, we most speak about change of traditional polymer with biopolymers, and the most important change of the green, change of traditional solvent with greener one. As investigated by this team, Drioli in Italy, with all of the membrane production factories, most of companies, about 70%, treat the produced wastewater. When we have a NIPS method, in the NIPS method, solvent go to the water bath during the coagulation bath, during the phase inversion, and we have a lot amount of water-based wastewater that have solvents. This solvent is also expensive. Some companies recover this solvent and reuse again, especially hexane, because hexane is a low boiling point. They usually distill the wastewater and separate the hexane. But separation of dematch NMP is very hard, and in some cases, without any treatment, drain the wastewater into the river, sea, and other places. The most used solvents is THF, NMB, DMF, dematch, and we must replace with greener one. There are different types of greener solvents, and the most famous is water. Water is no dangerous solvent, and if we can use water instead of DMF and NP, it will be very good, very, very good. But we know that the carbon-based polymers do not dissolve in water, and water is a non-solvent, not solvent. But there are some membranes can be used water for fabrication that I will discuss. In the case of the definition of the green solvent, we say that a green solvent is low toxic, low volatile, low flammable. The flammable can be dangerous in some cases. Renewable, that means have bio-based green solvent. Biodegradable, if we have a solvent that can be biodegraded with microorganisms, after the application, we can treat the wastewater. But many of solvents are toxic for microorganisms, and we cannot use bio-based or biology for treatment of wastewater. As you know, we have 12 principles of green chemistry for reducing of the environmental problems. And you see that three of these principles is related to the reducing of the toxic solvents and use of biosolvent or green solvent. Therefore, we see that the replacement of traditional solvents with green solvent is very important. Some companies in the world categorize the solvents based on the greener behavior and suggest some solvents can be replaced with the toxic. For example, these companies produce these tables and says that, for example, methanol with these properties can be dangerous in this area or low dangerous in this area. And we have many companies discuss about, and we can, having of these tables, we can select that which solvent have low toxicity, and we can replace with our solvents. This table of these companies that shows that, for example, this butanediol from the flammability is a bad, but from the waste is the average. Therefore, give numbers for these solvents, and based on the process and the application from healthy, flammability, environmental impact, we can select the lower toxic solvents. Generally, when we see these tables, we can categorize the solvents as a very hazardous, highly hazardous, and when go to the right, the hazard is reduced, and this solvents is good green solvents. For example, when we have this table in the membrane fabrication, we use that our used solvents in the membrane fabrication is located here, DMAX, DMF, NMP. It's hazardous, okay? Chloroform is very hazardous. But in the membrane fabrication, we use DMSO. You see, dimethyl sulfoxide is also a solvent used in membrane fabrication and can be replaced DMAX with DMSO. Okay? When we go to the right, the toxicity is reduced. If we can prepare a membrane with DMSO, we must use DMSO because DMSO is greener one, and go to the right. Or toluene. Toluene is better than THF if we can use toluene. Therefore, with going to the right, the toxicity is reduced, and you see this table is water and alcohols. Okay, most alcohols. Therefore, if we can use ethanol instead of, for example, methanol, methanol have low toxicity. If we can use ethanol, we must use ethanol, not methanol, because methanol have some problematic issues. Therefore, with this table, we can find a green solvents that we can replace with toxic ones. This is the usual polymers, and we must replace these usual polymers with biopolymers. Cellulose acetate is a bio one because fabricated from cellulose. During these traditional polymers, the cellulose acetate is green one. But others are synthetic polymers, and synthetic polymers have environmental problems. And these are the used traditional solvent in fabrication of membranes, and we see that DMSO can be categorized in this green. And if we can, for example, prepare cellulose acetate with DMSO, we have a good green membrane. But we have a big problems, and the first big problem that our selected solvent can be dissolved the polymer. First step of membrane fabrication is dissolving of a polymer in a solvent. First, the selected green solvent should dissolve the polymers. And in many cases, the good green solvents do not dissolve. For prediction of that our selected green solvent can be dissolved the polymers, we have some software and some calculation for prediction. One of them is Hansen solubility parameter for prediction of polymer. When we have a new polymer, new biopolymer, we want that this new biopolymer can be dissolved in new green solvent, and we have not in the literature that use this green solvents. We must first calculate that from thermodynamically view, it is possible that this solvent can dissolve these polymers. In the Hansen solubility parameters, we first calculate the RA with this equation. We have three soluble parameters, three different soluble parameters. One, D, is dispersion, dispersivity. Second is polarity, and third is hydrogen bonding ability. Okay? In the dissolving of a polymer in a solvent, first the solvent should adsorb, should interact with polymer for attachment, and the next diffuse inside of the polymers and separate the chains. The solubility, it means we separate the salts from together or the polymer chains from together. Therefore, for solubility of a polymer, first the solvent should be adsorbed, should be interact, go to the polymer body, and begin to separate the chains together for easy movement. When we have a soluble, we have a solution, we have a easily movement, but in the solid phase, we have not good movement, okay? Solubility is mean the easily movement of the change. For interaction of a solvent and a polymer, we must have good functional groups. We know that the polar solvent can dissolve polar components. Non-polar dissolve non-polar, okay? Therefore, polarity is important and hydrogen bonding is important for interaction, okay? We must have an interaction and the parameter shows this interaction. One is polar, polar can dissolve polar, non-polar can dissolve non-polar. Therefore, when we have a polar polymer, such as polyvinyl alcohol, polyethylene glycol, a polar solvent, such as ethanol, such as water, can be dissolved. When we have non-polar, the non-polar solvent. Here, hydrogen bonding and dispersion. Dispersion is related to the diffusion of the solvent, and after the dissolving, the dispersion of the polymer chains in the solution. Therefore, we have 3 parameters, and with the difference of these parameters, we can